right, welcome back. We're going to pick up where we left off. We finished 2.9a, and we showed the calculator and the formula. So we're going to do question 2.9b. Same facts, little birth weight, but it's asking, find the quartiles. So we're going to call that quarter 1, quarter 2, which is actually the median, and quarter 3. So those are pretty easy to calculate. Again, especially with this fancy calculator we have. So I'm going to show you how to type these in. Pretty straightforward. And it would make sense if you made a picture. If that's this would be quarter 2, quarter 1. Quarter 1, the area under the curve would be 0.25 because that's what the word quarter means, 0.25. Quarter 2, the area under the curve, or the proportion to the left. The proportion to the left would be 0.25. The proportion to the left for the median would be 0.50. And for quarter 3, the proportion would be 0.75. So we can imagine that's the area under the curve. Well, if you know the area under the curve, it's the opposite of what we've been doing here, where they gave us the area, right? If they give us the area, we can do inverse. We want to go opposite. So here we found the area if we knew these 4 things. Okay, so we're going to go to the same spot we went before, hit menu, distribution, inverse normal. That's what we want. And now I have some different information. They need inverse normal, area, mu, and standard deviation. Well, on the last problem, we were given mu as 3668 and the standard deviation is 511. So those haven't changed. Just these areas under the curve. So area 0.25, mu 3668, standard deviation 511. Enter. Enter. Great. So I get for quarter 1, 3323.34, and these are in grams. So that's the weight of a baby who's heavier than 25% of other babies. So it's a light baby, but not low birth weight. Then we could do it again. Now the area is 0.5. 3668, 511. Oh, we already knew that, right? That's what it means. So the median in normal distribution, the median and the mean are the same number, and we already knew that, but that's interesting. It just confirmed it, didn't it? Interesting. Now we go to stats, distribution, inverse normal. Now we want the area 0.75. Ooh, I accidentally, so let's go back. I hit the wrong button there. Inverse normal. Okay, 0.75, 3668, and 511. Enter. Enter. There we go. Now, if I'm going to use a calculator, I have to show my work on my paper. If I don't, I get 0 credit. So I'm going to have to show my work here. I did inverse norm. You can also abbreviate this just INV norm like the calculator does. And we did 0.25, 3668, 511. And out popped that answer. This one we typed in inverse normal 0.50, 3668. And this one I would have been okay if you didn't show your work, because you don't really need a calculator to know that. That's kind of just common sense. Okay, then this inverse normal 0.75, 3668, and 511. Looking good. So now we're gonna go to the back. Now the fruit fly question, if you're not sure how to do that, So that's R2.11. You may want to review this strawberry question. It's exactly like the strawberry question. So if you're not sure, write down this code for YouTube and watch this video on strawberries that we went through in class and use it as a guide to do the fruit fly problem. Okay, now let's get to the back. So I'm actually going to skip this one as well altogether. I'd like to go over it in class. So if you get a chance to go over it, great. If not, you may skip it. So I'm gonna skip that question. Now, my next question says R2.1. So let's do it. Okay, so R2.1a. So this states we have 15-year-old males, and they are already set it to a z-score. So I'm just going to fill out my table here. So it says it is symmetrical, it is single-peaked, it is bell-shaped, and for this distribution, the z-score is 0 and the standard deviation is 1. Well, we're in heaven. That's the kind of answers we're dealing with. Now, they also said that the z-score corresponds with 170 meters, so with the centimeters. So they're basically saying the average 15-year-old male is that height, and they're telling us this number is 177.5 centimeters. So ultimately, what they're saying is x bar, or we also call this mu. If it's all the population data, we would call it mu. If it's just the sample, we call it that. That's the difference between this notation. So it looks like they're looking for the mean. Either symbol would have been okay for me. That's the mean. And they also want the standard deviation. So that looks like it's going to be 7.5 centimeters. And it said, show your work. So normally we get the mean, and then we have to add the standard deviation each time. So 170 plus the standard deviation would give me a z-score of 1. But here they provided this number at 177.5. So to solve for the standard deviation, we just subtract 170 on both sides, and we get 7.5. Okay, so that's our standard deviation. Now, what would be the height of a z-score of 2.5? Okay, so I want a z-score of 2.5. And so we can find out the area under the curve and maybe work backwards, I'm not sure. But if we actually look at the z formula, we know basically everything. If I want to know the z-score, or if I know the z-score, I can fill that in. So the z is 2.5. The actual height we don't know, so we're going to make that x. We would predict any 15-year-old to be 170. And we know, now we actually know the standard deviation is 7.5. So we can do a little math here. Now I tell most students, because they forget this from Algebra 1 and Algebra 2, that it's probably easiest here to just cross multiply and solve. Very useful skill. So I'm gonna cross multiply here. I get 2.5 times 7.5, and then I get 1 times that, which would just be that same number. Okay. So using my calculator, okay, and then to get my final answer, I'm just going to add 170 to both sides. And these are in centimeters. So that's a very tall person, especially if the average is 170, and that's the height. Thanks for joining us. Tune back in to get the rest of the questions on the worksheet.